Welcome again. So in the last lecture, I was unable to finish the lecture because of some technical reason. So I'm just continuing from that point. So I was discussing about this particular time domain expression of the VSB modulation signal. Okay, so I told you that we have this particular equation. We have HIT equals to H nu T cos omega CT. So if we take the Fourier transform of this particular equation, HIT equals to H nu T cos omega CT, then we can see that if we have the Fourier transform of H nu T equals to something HVF, then because it is multiplied with the cos omega CT, we have seen several times that this frequency spectrum of H nu T is going to be shifted around FC. Okay, so it will be H nu F minus FC plus H nu F plus FC and divided by 2. So that will be a factor, there will be a factor of 1/2. So this will be our Fourier transform of this particular equation. So as we have already defined that H nu F minus FC and H nu F plus FC should be equals to 1. Okay, in this particular frequency range minus W to plus W. Okay, then if you substitute this particular value equals to 1 into this particular equation, okay, here, then we will be getting HIF equals to 1 by 2. So once you will be substituting HIF equals to 1/2, then this HIF you can substitute in the equation of MCF here, okay. So this MCF will be equals to MF divided by, means MF multiplied with HIF. So HIF is, we are getting equals to 1/2. So if you calculate the inverse Fourier transform, you will be getting MCT, that will be equals to MT divided by 2. Okay, because we are getting here it is MF divided by 2. So we will be getting MCT equals to MT divided by 2. Similarly, we can also take this equation. Okay, we have already defined this particular equation MS F, which is equals to MF HQF. Okay, so what we can do again is we can similarly take this particular equation HQT equals to minus H nu T sin omega CT, and again we can calculate the Fourier transform of this equation. Here we are getting sin omega CT, and because of the sin omega CT, again the frequency spectrum of the H nu T is going to be shifted around FC, and because of sine we will be getting a minus 2j at the bottom. Okay, so minus minus sign will be cancelled out, and here we will be getting H nu F minus FC minus H nu F plus FC divided by 2j. So basically here we can get this equation as 2HQ. We can write this expression like HQF multiplied with the factor of 2. We can multiply it and divide it by j. So j can be transferred here, and once you will multiply it with j, we will be getting j square. So j square will be equals to minus 1. So if you take this minus 1 multiplying in the upper half, you will be getting this sign as a plus, and this will become negative. So here we can write this expression as, for example, H nu. It is again written wrongly, so please make it correct. This expression will be something like H nu F plus FC minus H nu F minus FC. Okay, because there will be a sign change. Okay, so please do this correction. Okay, so I'm again dictating you this expression should be, because we are multiplying with the j. Okay, so even at the bottom of this we can multiply it with the j, and here again it is j, so j square it will become j square, so j square equals to minus 1. So there will be a sign change. This will become positive and this will become negative. So here it will be H nu. We will be getting F plus FC, and here we will be getting minus H nu F minus FC. Okay. So obviously we already have seen the form of H nu. So this is our form of H nu that we have defined in the previous equation. Okay. So we have defined this previous equation. This particular form we have defined. So if you take this form, and then we can calculate this particular differences. Okay, if you calculate this difference, okay, in which H nu F plus FC and minus H nu F minus FC, then we are going to get this type of response. Okay, we are going to get this type of filter response that we can verify easily. Okay, it is very easily verifiable. So we are going to get this type of frequency response. So basically, if you see from this canonical representation of the VSBS signal. In the previous case, we have defined the canonical representation by this equation. Then by just having this expression, what we can do is we can draw a block diagram in which we can have a phase discrimination method for generation of the VSBS signal. So how it can be done, we can see that we have to take the message signal first. And as we know that MCT is same as MT divided by 2. Okay, so first what we need to do is we need to take this particular message signal MT, and then this message signal has to be divided by a factor of 2, so that will be generating MCT. Okay, and then the same message signal MT will be passed through a filter with frequency response HQT. So we have already defined it. Okay, it is MCT, MST is equals to MT convolved with the HQT. So basically we have to take a frequency response, impulse response, or you can say that a filter whose characteristics will be something like this. Okay, it will be something like this. Okay, so this type of frequency response or filter we have to choose. And then we have to make this circuitry. Okay, and then we have to pass through this particular SQT. So this particular filter, we have to pass the message signal to get the MST. Okay, and then we have to take the carrier AC cos omega CT, and then we have to take a quadrature carrier by having a 90-degree phase shifter. We have to multiply it, and to get this particular result, we are going to get AC MCT cos omega CT, and here we are going to get AC MST sin omega CT. So after having this addition, okay, if we take the negative sign, we will be able to, like in the previous equation, we can see that if we are having this negative sign, okay, we are having the negative sign, then we will be able to keep the almost upper side bend, okay, a complete part of the upper side bend, almost complete part of the upper side bend, and a very vestigial part of our lower side bend, a very small part, okay. So little part of the lower side bend will be added. If this sign is to be positive, okay, then we have to keep the entire lower side bend, and then we have to add a little part of our upper side bend, so that this sign reflects. So this way we will be able to generate our VSBS signal, and this particular equation represents the canonical form of time domain expression of the VSBS modulated signal. So now I would like to further extend that why we are using the vestigial sideband modulation. So if you remember that I told you about different modulation schemes, for example, conventional AM, DSBSC, SSBSC, okay. So as we know that we want to send a different type of message signal, for example, voice signal, human voice signal, and then we want to send audio signal, then we want to send the video signal. So if you think about the video signals, I have already explained that the video signal bandwidth is up to 4.5 megahertz, and it is starting right from the 0 hertz. So from 0 hertz to 4.5 megahertz, we have the spectral component. And this particular message signal, video signal, don't have any spectral null. Okay, it is not having any spectral null around the DC, and therefore it cannot be sent through the SSBSC modulation. We cannot go for this single sideband modulation. Okay, single sideband suppressed carrier modulation we cannot use, because it is not having any spectral null around the DC. Second thing that we have to understand is in case of DSBSC signal, okay, can we send it through the DSBSC signal? The reason is that we cannot send it through the DSBSC signal because of the requirement of large bandwidth, okay, because video signal itself is occupying 4.5 megahertz. So if you send this signal through this DSBSC modulation scheme, then it will be occupying the bandwidth of 9 megahertz, and that bandwidth requirement is very much high. And therefore we are looking for a particular technique in which the bandwidth requirement should not be very high, okay. So that can be made as small as possible. So basically because DSBSC and SSBSC both are not suitable for transmission of the video signal, we generally send the video signal through VSB modulation technique. So what we do is we are choosing a particular carrier, and then we are sending the complete part of one of the upper sideband, and a little part of the lower sideband is also retained. Okay, therefore the bandwidth requirement will be a little bit greater than the 4.5 megahertz. Normally, practically, we are taking 6 megahertz as the bandwidth of the video signal. Okay, we also send the audio signal along with the video signal, because all the video signals will be containing both the video information as well as the audio information. So basically, for transmission of the video signal, we do use the VSB modulation. Okay, so here you can see that if we talk about what is the bandwidth of the modulated signal, VSB modulated signal, that will be equals to, here we can see it is FC plus W. Okay, so what we can see is our bandwidth will be FC plus W minus FL. Okay, it is FC plus W minus FL, that will be our bandwidth. Okay, so that you remember, the bandwidth will be, you can see that if we are knowing the bandwidth of the vestigial sideband. Okay, if it is FC minus FL will be over the bandwidth of the vestigial sideband, then the vestigial sideband bandwidth plus W will be the bandwidth of our total massive signal. Okay, total modulated signal. So here you can see that it is obviously, it is the, if we want to write this in this form, it will be FC plus W minus FL. Okay, that will be giving you the total modulated bandwidth. Or otherwise, in the other form, you can write that from FC to FC plus W, the bandwidth is equals to W. So W plus, you can write the vestigial sideband bandwidth. Okay, so if it is denoted by, obviously it will be denoted by FC minus FL. So if it is directly given, then you can add them. You can add that particular quantity directly to the W, that will be giving you the bandwidth of the VSB modulated signal. So I hope this discussion must be clear. Okay, so please try to go through this all content. Okay, if you have any query, please drop me a message in the chat box. Okay, in the comment box, I will be trying to clarify it further. So thank you for watching. I will be coming up with the next lecture in the coming videos. So stay connected with the channel. Thank you for watching.